Okay, so in this video, we're going to finish the lesson we started on partial fractions. So we started in class, and I shared the notes and another video that that can help with those who did not attend this lesson or need more teaching on that concept. So I shared that video plus the notes for those who did not attend class that day. And today in this video, I will cover two more concepts or two more cases of partial fractions, how to handle these cases when they are surfaced in case of converting one fraction into partial fractions if the denominator is presented with these characteristics. So far we covered those two types in class, and we gave some examples. We worked on some examples for them, but we're not going to forget that the first thing to do when converting a fraction into partial fractions, we need to convert the expression in the denominator into a complete factored form. So that's the first thing ever that we need to do when transforming the fraction, a rational expression into partial fractions. So we covered these two cases where you have the denominator q that is only an expression that can be factored into linear non-repeating factors only. Linear non-repeating factors only. So that's the first case that we covered with examples. And then we looked at the other case where the denominator q can be factored, but there are some repeating factors. Now, this case you need to be careful with it, because if you have say you have an expression that is linear but that has a factor through a power 3. So say you have one linear and one non-linear. You have two linears, but one of them has only power 1, but another one has a repeating factor that is 3 times repeating. 3 times repeating. Then you're going to have one fraction for the one that is linear non-repeating. And then you're going to have 3 times the one that has the repeating factor 3 times. So say, let's give you an example. I'm going to give you a quick example. Say you have 3x squared plus 5. Let me take another example. Let's say 3x squared plus 18 minus 18. I don't know, 3x squared over x plus 1 times x minus 2 to the 3rd power. So how you would break this down, you're gonna need one factor, a over x plus 1, because this one does not repeat, you are okay with it. But this one that is repeating 3 times, you're going to have 3 fractions for it. One with the denominator that has the power 3 with power 1, going down until the power is the 3. So a b over x plus x minus 2 plus c over x minus 2 squared, because it's a repeating factor, plus d over c minus 2 to the 3rd power. And then now you can go and multiply by the least common denominator, which is always going to be this, and then simplify that. So that's if you have a repeating factor with linear expression in the denominator. And today, what we're going to look into is when you have irreducible quadratic expressions in the denominator, and when you have them repeating. So if you have a irreducible, so that means an expression, a quadratic expression that you cannot factor. And then also we will take the other case where it's repeating. So we're going to take a look at all these cases in this video for you, and I needed to go over this quick review to give you the brief idea of what it looks like from our previous class. Now let's take this example where you have non-repeating irreducible quadratic factors in the denominator, right? So, well, when you have that, since it's non-reducible, and then the degree of this expression in the denominator is 2, then you should think about the top expression that has a degree 1 less than this denominator. Again, if you have a factor that is a quadratic expression with an irreducible, non-reducible, right? You need an expression on top that's not just a constant like we were doing earlier or we were doing last week, but you do need an expression with a degree 1 less than the bottom. So if it's 2, then you want a degree of a linear expression on top. If it's a quadratic expression, non-reducible, non-factorable in the denominator, then you need a linear expression, ax plus b or on top. But first, we need to factor denominator completely, right? So here's an example we have. I have this example, but this expression here, we need to remember how to factor it. This is the formula. This is x cubed minus 1, which is also x cubed minus 1 cubed. The formula you need to remember here is if you have a cubed minus b cubed, right? It equals to a minus b times a squared minus, or actually that's plus ab plus b squared. So a is x and b is 1. So this would be x minus 1 times x squared plus x, just 1 times x plus 1. So the two factors that we have, the first one is a linear that goes with the first case that we studied in this topic. And then x squared plus x plus 1 it's not, you cannot find two numbers to factor one by that will add up to one. So that makes the x squared plus x plus one a non-factorable or reducible expression, quadratic expression. Then it goes to the case that we are studying now. So let's rewrite the expression as the denominator being completely factored. So we're gonna have 3x minus 5 over x minus 1 times x squared plus x plus 1. That equals, say, I need a constant for the first factor on top of it, x minus 1. But the second part will be, I'm going to need a linear expression because it's a non-reducible expression in denominator that is a quadratic. So x squared plus x plus 1. And that I'm going to simplify. I'm going to try to find ABC, right? And first thing, we would want to multiply by the least common denominator over here, which is the denominator of the first side of the equation. So I would multiply by the x minus 1 times x squared plus x plus 1. That's what I would multiply the whole thing by, and cancel what we can cancel, keep what we should keep. So x, the first one is gone. I'm talking about the denominator, multiply, it cancel, they cancel each other. So that's 3x minus 5 here, equals, for the second part on the other side of the equal sign, x minus 1 is gone. So that's a times the one that's left, x squared plus x plus 1. And then for the second part of the other side, x squared plus x plus 1 is gone. So I'm going to be left with plus bx plus c times x minus 1. Now let's distribute and create the equations to solve this for ABC. That's all. That's what we wanted. That we want to find ABC. Well, that's 3x minus 5 equals ax squared plus ax plus a. And this one we FOIL. That's plus bx squared minus bx plus cx minus c. Now we're going to regroup the terms by power of x. Group them by powers of x. 3x minus 5 equals, we're going to take the power x squared. So that's a plus b with x squared, because these are only these two, right? We don't have other x squared. Now let's see if we can find the x's. So the x's will be plus ax minus bx and plus cx. So a minus b plus cx, and the constant terms a minus c. So now we have we do not have x squared. That means you have a 0 x squared on this side. Would be a plus b equals 0. Second equation will be the x1, the x. So we have a minus b x, minus b, sorry. A minus b plus c equals 3. And then last one is a minus c equals negative 5. So I see now if I match the two last equations, that cancels the C, right? Then I'm gonna have A, 2A, right? 2A equals negative 2. And then bring the 2A plus C, B, minus B, sorry. That's 2A minus B equals negative 2, and bring the top one with it. So bring it here, match it with the top one. So that's going to be A plus B equals 0. So that means if we add these two, B is canceled. So we have 3A equals negative 2. 3A equals negative 2. Divide by 3. If we divide by 3, then you have A equals negative 2 over 3. We found A. And then we're trying to find B. That's going to be easy to find B because B, from the first equation, we have A minus B, A plus B equals 0. So A equals negative B, right? From this one. So then you're going to have B equals negative A. So that's 2 over 3 because A was 2 over 3. So then we have the B. Let's find C from the third equation or the second equation. Let me use the third equation. That's better. We have A equals negative 5 plus C. Well, actually, we want to solve for C. So let's say instead C equals A plus 5, right? So that C equals A plus 5 from the third equation. And we know A equals negative 2/3. So C equals negative 2/3 plus 5. So C is C is 13 over 3. We have A, B, C, then we can write the partial fraction form of this rational expression. That is A was negative 2/3 over x minus 1 plus B was 2/3 x plus 13/3 of x squared plus x plus 1. And then it's okay to keep it as the fraction, but if you want to, your expression can be like, I want you to not trying anything that will get you in trouble, because if you stop here, you get full credit. But if you move forward to simplify it the way I'm going to show you and make mistakes, then you lose points. So that's fine if you keep it there, but this is the most simplified form and really most pretty form. So that's negative 2. It's negative 2 over 3 times x minus 1 plus 2x plus 13 3 x squared plus x plus 1. So this is prettier, obviously, but I don't think it's more complicated than that. But it's okay if you feel like, all right, let me give it in the ugly form to avoid making mistakes. And I would totally be fine with that. Okay, so that was an example of when you have a non-repeating, irreducible quadratic form in denominator. Non-repeating, quadratic, irreducible. Now let's see when you have a repeating. Well, you are used now to repeating factors already. If you have repeating factors, the number of times this factor repeats indicates the number of fractions you're going to create based on that. And then that said too, you're going to make sure that you go down each fraction, you go up one unit power each fraction. Also, how do you know the quadratic expression is irreducible? Well, it's irreducible when the discriminant is negative. Discriminant formula is b squared minus 4ac. If this value is negative, then your quadratic expression is not factorable. Or if it's, even if it's positive, sometimes it's not. It may not be factorable, because if you cannot find two numbers when you multiply a and c, two factors of this product that add up to b, you're not going to be able to factor this expression. And then that be a situation where you want to go ahead and do the same as irreducible expression, quadratic expression, whether it repeats or not repeating. Now let's see this example. For this example here, we are thinking about what situation is it? Well, I see x squared plus 4. X squared plus 4, any quadratic that potentially, if you're solving it, will give you a complex number, a solution, is irreducible. Now, but because of that, you're going to think about the way that we break it down with irreducible quadratics. So I'm looking at this. There is 100% possibility for me to get a quadratic, imaginary solution. So that said, we're going to consider it as a irreducible quadratic, or if you want to use quadratic formula, if you want to use the discriminant formula, that is b squared minus 4ac, that is the b for the bottom. I'm working with the bottom only, the quadratic expression in the bottom. So b equals 0, so 0 squared minus 4 times a 1 c 4, that equals negative 16. So it's less than 0, so we have a irreducible. See, it says, and b squared minus 4ac negative, then in the partial fraction decomposition, p over q allow for the terms this. So the term that's, you see, you go with the first one with the linear expression on top, then you go up 1 for the power, and then you have a second linear expression, so on until you get the power, whatever it is. So you go up 1, 1, 1, and get the power up until you get whatever the power that was given to you in denominator, then you stop. So in this case, it's just 2. So we're going to write it like x to the third, and it's already factored, so we don't have issue with that. X to the third plus x squared over x squared plus 4 squared equals, then now we have the first one, that's ax plus b over x squared plus 4 plus, maybe I need a cx plus d over x squared plus 4. Now the power is 2, because if I had a power 3, then I would need another fraction. But now I have the power that is, the power is 2, then I need only 2 fractions with linear expressions on top, and the power 1 for the irreducible quadratic, and then the power 2, which is the power given to me. Now let's multiply by the LCD. We know that is the x squared plus 4 squared. So we can cancel the denominator. We multiply by x squared plus 4 squared, the whole thing. So that is x to the third plus x to the second equals, that's 1 time the x squared plus 4, because it can, one of them is canceled, times ax plus b. Then when you multiply by the third fraction, everything is gone. So we are left with plus cx plus d. Now we do FOIL to cancel the parentheses. We got we got x cubed plus x squared equals ax to the third plus bx squared plus 4x, 4ax. I said bx squared plus 4ax plus 4b plus cx plus d, correct? Now we're gonna regroup them by powers of x. So x squared, x cubed plus x squared equals ax cubed by itself plus bx squared by itself also, plus 4a plus c x, and then plus 4b plus d, right? Plus 4b plus d. So based on how this thing is presented, we're gonna have this a x cubed and then x cubed here, so a equals 1. So we have bx squared and just x squared here, so b is also 1. So we're going to have 4a plus c, no x term, so on this side, so it's 0, on the first side, so it's 0. And then 4b plus d, no constant term on the first side, also 0. So that's the system we're going to solve. Easy to solve because we have a, then we can have c. So that's 4 times the value of a, 1, plus c equals 0, which is c equals -4. And same thing here, we have b, then we can find d. That's 4b equals 1 plus d equals 0. So we have d equals -4. So we can write the partial fraction form of x cubed plus x squared over x squared plus 4 squared. That is the expression that we had, x cubed plus x squared over x squared plus 4 squared, that equals the fraction form, the partial fraction form, x plus 1, which one, the ax plus b, a equals 1, b equals 1, over x squared plus 4, and plus it's negative, or if you want to use the negative on the outside of the fraction, that's totally fine too. So that's 4x, or if you want to factor the 4 out, right? 4x plus 4b, 4x plus 4, but I'd like to factor the 4 out. So that's 4x plus 1 over x squared plus 4 squared. That is the fraction, partial fraction form of x squared, x cubed plus x squared plus x cubed plus x squared over x squared plus 4 squared.